Welcome to this episode of Robots in Depth. Today we're going to have some slightly different content, but I love all this stuff. So we're going to talk to Nicole Immorlica from Microsoft Research about game theory. And I'm so fortunate that I get to go around the world and talk to all these fantastically interesting people. But we're going to start where we usually start. How did you get into the field? What's the first step of your journey that eventually put you here?
Well, I wanted to do physics when I was in high school, actually. And so I went to MIT for undergrad, and I was pursuing physics and mathematics, and my parents thought that maybe it would be good to have a better, more reliable career path, so they encouraged me to pursue computer science. And I loved it, but I always wanted more of a human element, especially as I got older. So as I went to grad school, I was looking for a way to relate my research to society and to use it to help me understand the world around me. And I ended up taking a class. We were able to cross-register at Harvard, so I took a class at Harvard with Al Roth, who's an economist that won the Nobel Prize recently here.
Not a bad teacher,
in Stockholm, right? I guess, yeah.
Yeah, we're actually in Stockholm. So this time you're not visiting Stockholm for the same reason he did, but I'm sure that's going to happen in the future, right?
Yeah, well, we'll see. But so he talked about, market design and using mathematics to model human behavior and predict how humans will behave in the context of a market, and then how you could set up the rules of the market to optimize the outcomes that happen naturally. And that was just fascinating. So I got into it through that course.
Yeah, and we're talking every kind of market, right? It can be interhuman relations, it can be pork bellies, it doesn't necessarily have to be what we traditionally see as a market, right?
Oh yeah, for sure. So I mean, he's famous for doing kidney exchange markets. In that course, I studied labor markets where you match medical residents to employers, but also in my research later on, I started looking at social networks and sort of the market for information. How does information spread in a social network? So yeah, market is a very broad term, and it basically encompasses anything that we do in which we interact with one another.
So the market is kind of a definition of an area where intelligent agents interact, right? Yeah, I mean,
yes.
And they might also not be human, they can be machines, right?
They can definitely be machines, and I guess I'm here at this conference, which is an AI conference, although my background is mostly theory. But I think the reason that they invited me to speak here is because they're interested in how machines and humans interact, and you can use a lot of the same reasoning about how humans interact with other humans to predict how they would interact with machines as well.
Yeah, and this is of course essential if we're supposed to design and build both artificial intelligence systems and artificial intelligent robots. We have to interact with them, and we have to design the robot to adapt to the human, but we also have to educate the human to be able to interact with the robot, right?
Yeah, so I think there's an important element of design in the sense of we have to make the systems sensible to the humans such that their natural perceptions enable them to optimize their actions. So it has to be something that a human can understand, and there's definitely that factor when we design machines for humans to interact with. But that even exists in more traditional markets. So you can think about say an auction design. How does the interface look to the human? So at Microsoft, for example, we're building ad auctions, right? And we have to think about how to write the software such that the way that you would optimally bid on different keywords in the ad auction makes sense to the person who's doing the bidding.
So that optimizes their experience, and then of course the total the whole thing of running this auction platform is optimized, right?
Yeah, so it's very important to optimize their experience because the platform, at the end, we eventually model the human behavior mathematically, but that model is accurate only if the humans completely understand what's going on. So that's why it's important to optimize their experience.
It's kind of a very advanced user interface design, you can say.
It is, yes.
And without a good user interface, the customer will misunderstand or misinterpret, and therefore won't use the service optimally, and the outcome would be less than great, right?
Correct, yeah.
Yeah. So you use it in that context. Have you also seen other uses of so-called game theory in practice? This is a very concrete thing. Hundreds of thousands of people are working with this every day, and that's cool to see such a problem.
Yeah, I mean, so that there's, within Microsoft, there's many applications of this game theory agenda, but also even more broadly, you see people reason about it when they want to understand, like, warfare, so sort of the famous prisoner's dilemma about whether we should try to attack one another or, hawk and dove type games. So you can use it to reason in the political arena. You can use it to reason about information and social networks. Are people going to eventually learn the truth? And what sort of structures of social networks will enable people to learn the truth. You can look at it in recommendation systems and things like that. So can we get people to explore different agendas or different, say, like, you want to have a recommendation for movies and you need people to explore different movies. So you have to make recommendations that might be suboptimal for them because you need them to explore that movie, or routes in a driving network, like in Waze or Google Maps and all this stuff. Yeah, so it's really infiltrates our entire lives.
I would presume that not everybody is familiar with, and I would benefit from a definition of game theory. And before we start more on how we use it, how would you describe it for the lay person, right?
Yeah, that's a good question. So game theory is a study of the outcomes of human interactions. And so each human, which we often call an agent, so this, it could be a human, it could be a machine, but there's an independent actor that has a personal objective function that they're trying to optimize, like maybe their wealth, for example. And then there's a set of actions that this person can take within the context of the game. And there's the question of what scope do you want the game to encompass? Is it their entire life, or is it like their shopping behavior at the supermarket, right? But within whatever scope you define for your game, there's a set of different actions that the agent can take. And other agents in the system also are taking actions at the same time. And then the outcome for the individual is going to be a function of the action that they chose and the actions that the other people chose, and perhaps some underlying state of nature. And then that's going to give them some value for the objective function that they were trying to optimize. And so game theory looks at equilibria in which everybody is performing the action that is best for themselves given what they know about the world and what they expect other people to be doing.
And in robotics we have this additional problem of the signal, the data we get being very fuzzy. There is also delay because some agent out there in this field is taking a decision and you're taking a decision at a particular time, but you don't know of each other's decisions because that information might not come at all to each other, but it might come also with a delay. So at a certain time, we both took a decision, and a time in the future, that information is then shared between us, and then we have to not only take a decision today, but also predict what are the other people going to do, right?
Yeah, so you're getting a little bit into the notion of a dynamic game, so games that evolve over time. These are traditionally, like, they're really much harder than standard games, than simultaneous move games, because I can do things like, punish you if you take an action today. Tomorrow I threaten to punish you if you did something today that I don't like.
Yeah. If for instance, the employer doesn't pay the employee would say, I won't show up for work, right?
Right, yeah.
And of course, the employer knows this. So this is kind of a known thing, right? Because the employer knows that if I don't do this, there's a consequence.
Correct.
There's also the things that you don't know happen because of your actions, and then you have to try to learn from them, right? Is this also something that it's a dynamic, but also maybe kind of a machine learning thing that, oh, okay, I tried that and had this consequence, and I won't do that again, or?
Yeah, so this depends a little bit on how you model the information or the knowledge that the agent has when he chooses his actions. And so in a repeated game, you could take a Bayesian approach in which you model this information set with some distribution, some prior. And when an action is taken and the agent observes the outcome, they might update their prior about the value of that action. And so in a sense, they're learning over time what the benefits of different actions are.
Because that's in a simulated game, and as you say, as a turn-based game where I do one thing, everybody knows I did it, and then somebody else does another thing. This is kind of a simulation, if you say. But when we come out to real-world robotics, that isn't possible because information takes time to disseminate, and it disseminates very unpredictably. So it becomes more closer to the real world application. We talked about this bidding and auction site. When I bid, I don't actually immediately know what somebody else does, or what somebody else is considered doing, right?
Correct, but you might know something about like the sort of distribution of the value they have for that thing that you're bidding for, which then you can infer if this is the sort of the set of values they might have, then this is the set of bids they might make. And if you can sort of think about the probability with which they make each bid, and then you can try to optimize your action and expectation over the bids of that other person. So this is typically how we deal with like sort of unknown information.
Yeah, very interesting, because of course the prediction is a whole nother layer of a problem on top of the first problem, right?
Yeah,
very interesting. So you use this in many times. Do you see outside Microsoft, you see what's the state of research in the field, because of course you're more intimately familiar with this than most, right?
Yeah, there's a lot of things going on in the field right now. So there's a lot of interest of incorporating data into the design of markets. So, can I observe as the market designer, can I look back at the past and see what agents did and use that to update my design today such that it's more optimal? So can I learn the optimal design using, say, samples of the bids from the past? And this gets a little bit complicated if the bidders themselves also persist throughout time in the same system, because then they'll start to reason like, oh, this person is using my bid to re-optimize the auction, so maybe I should bid low, so they think that all the values are low. Right.
It becomes a very messy thing, messy feedback loop. Everything feeds back to everything. That's a very interesting facet of this, because this, of course, more or less already happens when we've all bought something on an action site like eBay or something, and we all try to say, what should I bid? When should I bid? So we're already trying to do that, guessing what the person on the other side of the screen is trying to do, right? So do you see, what is our state of knowledge about that facet of this problem? Do we know how to handle that, or is this?
There's a bunch of different theories, and there's a bunch of startups or mainstream companies that are implementing things in different ways. It's I'd say it's a very active area of research.
Because again, we're coming closer and closer to a real world or a more realistic way of saying the problem, right? The turn by turn, everybody knows everything. It's a not very realistic model of the real world, right?
No, it's not.
So we use this in this area. Can you tell me anything about an area that you were very surprised that we used it in?
Well, before we get to that, I do want to sort of push back a little bit on the unrealistic
Absolutely, that's exactly what the show is about, right?
So I would say that it's highly valuable to abstract away key elements, and it might be unrealistic sounding, the assumptions we make, like, for example, that an agent has a well-defined utility function or this this objective I was talking about, right? And that they understand which actions are going to optimize it. You might disbelieve that they're able to simultaneously find these equilibria, and there's some research in that direction suggesting that it's computationally difficult in a worst case setting. But the thing is that, like, all these abstractions, and I'm a theoretician, so I live in abstractions, and abstractions are very useful for understanding the world. They give us a lens that allow us to focus in on a specific aspect and understand how like perturbing that aspect would impact the outcome, and it might not tell us like exactly what we should do in a given situation, but it'll give us some intuitions like, oh, this is really important. So for example, another area of my research is looking at social networks and trying to understand how information spreads in social networks. So I have some sort of model of how an agent might behave in response to information around him, and I ask, okay, so if an agent is absorbs information in this way, under what conditions will eventually everyone in the society learn the truth about the world? And what I can observe is that it's very important to have a social network structure that is both sparse in the sense that there's no agent is too central to like listened to in a sense, and also expansive. So in the sense, and this is a technical graph theoretic term, expansiveness, but what it basically means is that everybody is able to transmit information to everybody else without too much effort. So like there's no cliquishness, there's no sort of closed communities that don't listen to the outside world.
Okay, so everybody can reach everybody, and everybody's capability of reaching everyone at the same time is limited, right?
Yes.
Yeah. So it's truly a very flat landscape in this case, because everybody's got access to everyone, but it's flat from that perspective, huh?
Yeah, so these are sufficient conditions for the nice outcome that I described, and they actually tend to be realistic in social networks. So, you don't have more than 500 friends on Facebook, right? Like are people that you actually know and listen to on Facebook. So in a sense, you're pretty limited in how many people you influence in social media. And at the same time, like there's a lot of trails, a lot of paths from you outside your little subgroup.
For instance, Facebook is limited to 500 friends. You can then have other forms of followers, and most social networks are limited to some extent, right? It might be 5,000, it might be 30,000.
Sure, and I mean, even if the technology doesn't limit you, like human cognition limits you.
The bandwidth simply of dealing with your flow. I mean, we see that on Twitter maybe, where you have quite a number. I follow a lot of people, and some people do, and I see that poses a challenge, eh?
Yeah.
I love Twitter, but it's also a challenge to deal with, right?
Yeah, you can't like just be reading your Twitter feed all day long.
Well, even if I did, I'd still miss 99%, right? But at the same time, I think that this is something I understood when somebody talked about Twitter a long time ago, why they liked it. It felt like a town square. Anybody could go there. You followed a lot of people, and as you said, there was no cliquishness. There was no closed groups, because on a town square, of course, anybody that can go there, wants to go there, can go there.
Right.
So this characterizes the different network. It makes the networks fundamentally different. Are you fully open, any number of followers, any number of connections, or are you really closed, like a group that you have to apply for? Do you see different, I would presume you see different effects on the communication between these people on these different platforms, right?
Sure. In our mathematical models, we can see like if you had a whole bunch of completely closed groups, then it's sort of obvious there's no way for information to spread from one closed group to another closed group if they're like absolutely have no open doors, right? And so as a result, one closed group might just happen for random chance to believe, statement A, and the other group will believe statement B, and they'll never converge to a common ground truth.
No, they will never share enough information because we talk about these agents convincing themselves that by reading and taking in material, they will develop their own point of view, right?
Right.
Very interesting. Again, back to this area, we've seen it in markets, we've seen it in social networks. as you have a greater knowledge of the area, where do you see this being applied where you were surprised that they could use it?
Game theory in general. I guess, like, you know, I've always thought about game theory as my way of understanding the world around me. So I pretty much apply it to everything in my life. Like relationships and
Give
everything.
us a few examples. The relationship part is cool.
Yeah. One thing that I was a little surprised how well it explained the world to me was using sort of game theory to explain behavior that's not optimal. So
very interesting.
There's this one theory that I really like about procrastination, where you can explain using game theory why agents procrastinate. What mistake are they making when they procrastinate? And the mistake that they're making is that they're overweighting today's costs in comparison to tomorrow's costs. So the sort of discounting they do for the future is incorrect from a technical perspective, but when they make this mistake, what the outcome is that they end up procrastinating. So I thought that was pretty cool.
Yeah, a cost we pay closer, a smaller cost we pay closer feels larger than a smaller cost we pay in the future, right?
Yeah.
Yeah, our perception is kind of skewed that way.
Yeah,
this is so interesting to see, because you have an intuitive feel, having immersed yourself in the field for a long time, you have an intuitive feeling for where there's something funny going on. And we all know this, when there is a field, we operate in a field we know, we can immediately tell what's out of bounds, what's out of the norm. And do you have any other nice example there? You said relationships, that's always interesting because most people can relate to it, right?
Yeah, I guess, you know, for relationships, I think about it's sort of a negotiation, right? You need to compromise to have a successful relationship.
Yeah, certainly.
And so you think about what you can give up in order to gain, and it's particularly sort of relaxing to think about relationships in a very logical fashion, so you don't end up getting mad at somebody when they ask for, or having an emotional reaction when they ask for something unreasonable, if you think about it as a negotiation strategy, and you can think, oh, that makes sense in the space of trying to reach a compromise. So.
And what I think is also that the fun part of relationships aside, this teaches us about being human. And whatever we learn about being human also teaches us valuable things when we do other things, right? Because if we don't understand ourselves as humans, we can't design systems that are compatible with us.
Sure. Yeah.
And we have to look at ourselves the way we actually are, not the way we wish we were, or we hope we were, or we think we are even. So that's kind of funny. I like that. And having been in a relationship for a while, there's certainly a negotiation. And I also see that you develop a lot over time. Your attitude really changes when you think more about this interaction when you have with this person for a long time, right?
Right.
Yeah, and that's fascinating, right? Where are we in? I mean, I know game theory has been something that's been studied for quite some time, right? I mean, this is an area that's a handful of decades old, right? In mathematics.
At least, yeah.
Yeah, at least, right? Where are we now? I mean, this kind of fundamental mathematical research takes time to trickle down into practical applications, although we see this in your bidding and optimizing thing. Where are we on the scale of this? Are we a mature field where there's reasonably easy to derive practical knowledge, or is it still lots of basic research needed, or?
I'm particularly interested in informing practice, and I think that we're really at a point where we can do a lot of that. You see this in a lot of public forums, like there were the FCC Spectrum license auctions. There's the school choice programs where we match school children to public school seats. There's the labor markets that I discussed in the beginning, kidney exchange. All these sorts of things are really able to make an impact today because we have such deep knowledge of the theory. But of course, they develop hand in hand. So for example, like, you know, we're starting to understand more in the theoretical realm about if you want to match multiple agents to multiple agents. So maybe, for example, you have cadet branch matching in the United States, and you need to match a cadet to programs that they will enter in the Army, and they need to have several of them that are adjacent to each other. So they have preferences over the bundles of the programs they might end up in. And how can I do this combinatorial matching? So there's some theory that was developed, and as soon as it was developed, people realized that it could be applied to this setting. Another example is affirmative action like things in school choice. Like, how do we manage to get our schools to be integrated in a way that we feel comfortable with as a society? How can I alter the algorithms in order to get them to acknowledge the diversity of an incoming class? And so this required some theoretical research and investigations of the pros and cons of enforcing this in different ways, and then we can see it in practice as well.
So what I understand is that the field is now mature enough, and the basic tools are mature enough, and the basic understanding is mature enough for us to actually come with a problem and then try to look at if we can use these technologies to solve them, right?
Right, yeah.
And if I am somebody with a problem, which means I'm probably not related to the field as it is. I have, through this description, heard that I have this problem, I need to optimize, I need to really know that I take, as for instance, the school thing. I have a business like that, I have run a community service like that. How do I get started? How do I train myself so that when I come to you, I can ask sensible questions, right?
Yeah, I guess there's two aspects to that question. One is you as a participant in the system, and one is you as a designer of the system. So let me answer both. I think maybe you were more asking the latter, but
both is perfectly fine with me.
So I think the thing I really want society to learn from game theory is that their actions have impact on their outcome, but the way that impacts the path that impact takes is that my action impacts your action. And so when I'm optimizing, I have to think about how what I'm doing is going to affect what other people do in the world around me, and how what they do is going to thereby affect what outcome I get. So there's this sort of extra step that I think a lot of people forget to take, which is, sure, what I do is going to impact how happy I am, but it's also what I do is going to impact what other people do, which impacts how happy I am. And as for the second thing which you asked, which was, as a designer, how can I set up a system that performs well? Like, you have to be the sort of all-seer that's taking this perspective into your mind, that like the rules that I construct are going to impact how people act and how they interact. And so you should, if you want to make it more formal, you should think about, what is the thing I'm trying to achieve here? Like, do I want people to end up with positions that they value highly? Do I want to have diversity within subgroups? You know, what's your objective? You could have many. Do I want to maximize revenue, right? And once you think of an objective, then you can ask how the rules will cause people to act to achieve your objective as well as their own.
Very interesting, because I think that if we could get more interest in organizations and in companies and in society in general of using these now well-established ways of optimizing situations, we could all get a better outcome in more situations, right?
That's true, yes.
Yeah, because I think you can say that with certain confidence, that these technologies applied in the right way will lead to more of what whoever designed the system prefers, right?
Right, and I really think that this is a robust way to do that. So, you know, there's a lot of ideas around in the world that, like, well, we should all just care about everyone around us, and we should optimize not for ourselves but for our communities.
Which in turn is optimized for us too, right?
It could. But the thing is, like, if you set the rules up such that when I optimize for myself, I also optimize for the community, it would just be so much simpler to live in that world, because I don't have to try and think about what's best for the community. I just have to think about what's best for myself. And I know myself very well, much better than I know the community. And so thereby I can act in a way that's best for myself, and the rules have been constructed such that it's also best for the community. So somehow it just becomes so much more, robust to misinformation and things like this.
In one way, I relate to setting up this show and doing the show in the way I do it, having no agenda, talking to a broad range of people. I love this. I'm curious by nature and by unobstructed habit, right? And it's also so that I think, as having done it this way, I also see the feedback from the community being very strong in the fact that researchers as yourself see that I do this, and I get so many suggestions from prior interviewees, and I just see this, exactly what you're saying. I optimized for what I prefer, but it also suited the community perfectly, and it just gets a very strong positive feedback loop, you can say, right?
Yeah.
So you get positive feedback, and is that a way of characterizing these systems, that when you get positive feedback from whatever you do, right? You lower the price, more people buy your product, you do it this way, you get more interaction or something. Is positive feedback a receipt that you're doing it right, or?
That's an interesting way of thinking about it. I guess you could look at it that way. So what I like to think about it is as growing the pie. Like, there's more wealth, that we've created more value in the world, then there's just a larger piece of pie to divide up among the people.
Yeah.
Right? And so you could think about the positive feedback as the pie growing. You're seeing that the pie is growing as you get more viewers on the system, right? And then because the pie has grown, this show has generated more value in society. It means that there's more value to be had by each individual.
Yeah, very nice. Because that's actually a thing. Say that I run some form of a system. It might be a communal service, it might be a company, and I have done this. How do I know how to improve it, and how do I know whether I'm doing the right thing? How can I study what I've done and then, of course, in the next step, take steps to improve it?
Yeah, you can run experiments, and this is actually, a lot of companies are doing this these days. You try to change a rule, see how people react to this change in your system, and measure whatever outcome you're trying to optimize and see, did it improve or did it fall behind? Now, of course, this is a little bit like a blind search. You're just changing rules arbitrarily. If you start to learn game theory or consult with economists or market designers, then you can have some guidance as to which rules might have which effect, and then you can narrow down your search onto the key factors.
Slightly more intelligent than just random throwing things at it and hoping it works, right?
One thing that's tricky in this field is, like, running these experiments. You often think, okay, I'll take half my customers and try to do thing A instead of thing B. But in a system like, say, an auction, maybe I take half my customers and I decide to set a different reserve price for them than the other half of the customers. But they interact with each other through the same auction. So even though I might hope that my treatment on this one group isn't affecting this other group, it really is because of this fact that we all interact, that my actions affect your actions, affect my actions, affect the equilibrium, affect the outcome.
Yeah. It's in absurdum, in ab nauseam, right?
Yeah. So it's hard to do a valid experiment in this world.
Yeah, and that's challenging, of course, because we can't just keep throwing darts at the board, and if it's then challenging to find a proper experiment that we kind of have a reason for running this particular one. So there is a problem there. how do we identify those, and how do we isolate, as in this A/B test, how do we isolate a group? That's challenging, right?
One thing you can do is try to find a group that's naturally already isolated. So, for example, New Zealand is often used for as an experimental base for companies like Microsoft because it's a fairly closed community. They don't, think if you do something in New Zealand, it's not going to affect pretty much anyone else.
No.
So
yeah, I know New Zealand is. I didn't know that, but I know that Iceland is popular among geneticists because they're so well tracked.
Yeah.
Because they have this very long history of writing down who's the mom and dad of who's the child, and finding those niches. So what you have to do to be successful is finding your New Zealand, whatever is New Zealand for your
that's one
domain.
way. That's one way to be successful. The other way is to try and track how the how the actions or how the treatment on this group will affect this untreated group, the control group over here.
Okay.
So that is possible in some settings, and that's actually the frontier of research in econometrics, which is not what I do, but like a lot of people are trying to understand this so-called network effects. Like how does the network of the participants cause the treatment to infiltrate the control and can we if we can understand the process by which that happens, we can sort of ex post remove the taintedness from the control
we can
group.
Clean the signal. So we do this in electronics all the time because the dirt is kind of known. You can remove it, right? And then get a cleaner signal and then take better decisions, right?
Yes. So even if you don't have a New Zealand, you could try to do things of that nature.
You can artificially do that, yeah. Very interesting. Thank you very much for sharing this information. It's been fantastic to talk about game theory. One of my game theory and emergent properties have interested me for more than 20 years, right? And thank you so much for sharing this and taking the time to do an interview.
Thank you. It's been great.